voted?
Yes.
One more.
Yes.
Hello, everyone. Thank you all so much for joining us this evening. We are excited to get through this, and I should have said this earlier, and I apologize. If everyone could please mute their line, that would be great. There's just a lot of people on the call, and there could be some background noise, so muting would be appreciated. It is awesome to see so many familiar faces on the line. As Jen and I are getting ready to talk about our next steps with Izak. It's an interesting feeling today. This is the first time I think I've seen Jen put makeup on in about 8 months, so I know it's a big deal. We currently are expecting around 150 people to be tuned into the reception, which is awesome, spanning from California to DC. So, oh, am I muted? Okay, sorry. So yes, we are so excited that you could all be here for the official kickoff for the Izak Fund for Heart Research. Although we haven't really begun our fundraising efforts yet, we've already raised over $11,500, and the majority of that is just in the last week alone. So that's awesome. Thank you very much. We want to thank those who have already donated. We want to thank you for those who are joining us today. It really does mean a lot that you take time out of your weekend to help celebrate and kickstart our new mission. So thank you very much. If you have a glass of something in front of you and you haven't emptied it just yet, please join us in raising it, as the Szymczak and Szelinsky family would like to cheers you for being here and welcome you to Team Izak. You are officially a warrior. Cheers, everybody. All right, a few housekeeping items before we get started. One last time, I will ask that everyone mute your line if you feel like you are not. And if you want to switch to speaker view, if you have not, that might be a good idea. It might be a little bit easier to follow along. As we proceed through today, there will be plenty of time for Q&A, and we ask that you use the chat feature for questions, as we will be monitoring those throughout the reception, and it will help facilitate the Q&A at the end of the reception. All right, so now on with the show. Tonight, you will hear from the President and CEO of the Children's Heart Foundation, the heart surgeon who has performed both of Izak's surgeries, and a thoracic surgeon whose focus is on single ventricle Fontan physiology. And by the time the night's over, you will know exactly what that means. But leading us off tonight will be my wife, who you are all probably very familiar with, Jen Szymczak, and she is going to share Izak's story.
Thank you, Tony. So again, thank you everyone for joining us today. Everyone here, I think, really understands Izak's story at a high level, but we just really wanted to take this opportunity to share some intimate details of just everything Izak has gone through in the last 2 years of life. So this is Izak's story. Izak was born July 16th, 2018. It was a normal pregnancy, and everything to our knowledge was great. When Izak was born, there was still no concern. We felt like we were pros, being this was our second go at being parents. On day 2 of life, they took Izak back for his 24-hour assessment. Conveniently, Tony had left to go pick up Bowden from daycare to bring him to meet his new baby brother. The timing was terrible. While Tony was gone, I was woken by a very serious, wonderful doctor to tell me that they heard a heart murmur on Izak. Fast forward an hour later, now sitting in their NICU unit, this same doctor told us that our baby had a bum heart and confirmed that his diagnosis was hypoplastic left heart syndrome. Only 1% of babies born with a CHD have HLHS. 20 years ago, this was a death sentence. Today, we have a chance of Izak making it to 18 years of life. 2018. This was our introduction to the world of congenital heart disease. To be honest, Tony and I couldn't even tell you how a normal, healthy, functioning heart worked, let alone one with a barely there ventricle. I don't even know what a ventricle was. That same evening, we were transported to Nationwide Children's Hospital, our now second home. Within 5 days of being in the cardiac intensive care unit, Izak was scheduled for his first open heart surgery, the hybrid. Enter Dr. Lanowicz. Honestly, Tony and I remember this distinctively, as our first meeting with Dr. G was on the morning of Izak's first surgery. Mind you, he had just finished participating in a triathlon, yet we never had more hope and security than after meeting Dr. G. We were told that we could be there for 30 days, but we were discharged within 14. Just enough time to be introduced to the heart world, learning heart language and terminology, seeing drawings and handbooks, meeting with so many medical teams, understanding outcomes and medicine schedules, and preparing to finally take our baby home. We were officially heart warriors on Team Izak. The next 4 months we were in isolation, as this time was extremely critical to keep Izak healthy and safe as possible until his next surgery. We tried to enjoy some normalcy as a family of 4, with a lot of hand sanitizer, masks, and Lysol spray. Needless to say, we were prepped for 2020. December 2018 was Izak's second surgery, the comprehensive stage 2 Glenn, which involved open heart surgery on bypass. They had to stop Izak's heart. Izak again crushed this surgery and recovery, and we were home within 9 days. Our celebration, unfortunately, was premature. 10 days later, we were readmitted to Nationwide Children's Hospital and back in the CT ICU. This was our first realization of the challenges Izak was going to face. As 2 full-time working parents and the 2-year-old at home, this was not easy to navigate. We were admitted for 78 days while trying to hold our jobs, be there for each other, as well as our 2 sons. During this admittance, Izak endured countless IVs, oxygen lines, a PICC line, chest tubes for drainage, MRIs, x-rays, weight checks, echoes, EKGs, sedated interventions, all while being NPO, which means nothing by mouth, no food, for 6 weeks. It was a hard wake-up call. This kid truly is a warrior. Those with HLHS are at a higher risk of developing intellectual and developmental delays due to the lack of oxygen that the brain received during pregnancy. Since being home this past year, Izak has been enrolled in occupational and physical therapy to assist where needed. Next up for Izak is the Fontan, Izak's 3rd stage in the 3 surgeries. This one also will include open heart on bypass again. The Fontan surgery is likely the last intervention Izak will receive before a heart transplant. Izak's heart will determine when the day for that new heart is needed. 3 years, 10 years, we pray that it's 30+ years from now. With the help of research and funding, we hope innovations one day will help delay the inevitable and give Izak more time.
And this is where the Izak Szymczak Fund for Heart Research comes in. The reason we chose the Children's Heart Foundation was because they wanted to partner with us to focus our fundraising specifically to peer-reviewed research that we choose. In other words, we get to select where our funds go. We get provided updates and insight throughout the research projects. We are included throughout the process every step of the way. And to talk about this in more detail and what the fund is going to do, I want to introduce Barb Newhouse. She is the president and CEO of the Children's Heart Foundation. And we met Barb last year at the Heart Walk, and she was really the driver of this idea behind Izak's fund. And we really want her to talk to you about it. So ladies and gentlemen, with no further ado, Barb Newhouse.
My goodness, that was quite an introduction. Thank you, Jen and Tony. And I have to tell you that this whole virtual reception, all of you from across the country, thank you for taking time and spending it with us, learning more about Izak's story. I would be remiss, I'm going to take 1 second to introduce Tammy and Scott Thomas. Tammy is our immediate past national chairman of the board. She also lives in Ohio. So, they have a wonderful heart warrior son, Adam, who is in his 20s. And so, you know, the good news about the mission of the Children's Heart Foundation is that we are here to advance the diagnosis, treatment, and prevention of congenital heart defects by funding the most promising research. We tend to stay away from more basic research. We leave that in the hands of others because our thing is moving research forward that allows the Izaks of the world, the Adam Thomases of the world, the Carter Nelsons of the world, the Jessica Cowens of the world to live in as young adults and then on into being old adults like me. So our research portfolio or program is based on, it's a four-legged stool. The first leg of our stool is we do an independent research. So we do it a call out. This year we had 65, which is a record number of applications come back in. Those were then scored at a high level and brought down to 21 research projects, which are now in the hands of the MAC for peer reviewing. Those that score the highest in that, we will be looking at, and that sort of the way Izak's Fund will work is Jen and Tony will be looking at all the peer review research, and if they see something that they say, you know what, this trips our trigger for us, we'd like to see our funds go to that, that's what will happen. And then we'll monitor it together. They might say, you know what, we're not seeing anything that's really making us real thrilled this year. And so we'll hold on to that money in a restricted fund. We are continuing to up our game in the research space on all sorts of things. And you're going to hear from Dr. Rodefeld in just a little bit. And I'm going to use him as my example in just a second. So that's the first leg of the stool. The second leg of the stool is we do joint funding with the American Heart Association. Now, because I know of Jen and Tony's, I have a good idea of their interests. If there is something in that portfolio of peer-reviewed research projects that come back where I say, Jen, Tony, you guys might want to take a look at this one. They might say, we'll fund that, which will be an additive into what we would do then with the American Heart Association. The third area that our third leg of our stool is a project called Cardiac Networks United. And that's really a big data opportunity for us. So when these guys, these great docs are looking for sample sizes, sometimes it gets a little tough based on what they need and when they need it. So Cardiac Networks United allows us to aggregate data in a repository to make it easier for them to get the sample sizes they need. So we fund that as well. And then our fourth one is we always need new researchers coming into the field. And so we fund fellowships through the American Academy of Pediatrics. So when Jen and Tony talked with me and said, you know, this is what we'd like to do, I said to them, rather than start your own foundation, work with us and we will make the types of research happen that you're looking for. Now, the Children's Heart Foundation, so I want you to, because everybody see my triangle, I look at it this way. Over here is the Children's Heart Foundation and the money that we put into research. We do seed funding. We start the process going. We get a Dr. Rodefeld so that his research has time, that he's got time to work with it and get it ready to go over to this side of the triangle, which is the big time funding that can come out of the National Institutes of Health, the Department of Defense, or come out of pharmaceutical industry. So we do the seed money, get them over here so they get the big dollars, and then there is sometimes once they get those big dollars, that there are still some areas that they're going to need some funding for. So the Dr. Rodefelds can come back to us and say, you know what, I'm going to need a little more funding for this type of thing that's not covered in the NIH funding. And we'll be looking at that as well. All of this is to get ready to go to that top. What's at the top? The FDA. That's when all of you and all of us together need to become advocates to the FDA to get approval for whatever the device is, whatever the pharmaceutical, the medicine might be, the therapy might be. We've got to all come together and work together in that way. That's what the Children's Heart Foundation does. We have one mission and one mission only, and that's research. I want to see Izak become Adam Thomas, Jessica Cowan, and then grow older. So where are we headed with research in the future? We're now at a point where we are starting to look at the neurodevelopment, the cognitive side of things, research into those areas. We are also looking at stem cell research. Dr. G will tell you, Dr. Rodefeld will tell you, there are not enough hearts to always go around. So we're looking at some real innovative research around being able to harvest a baby's own stem cells so that perhaps we can create a heart from using their own stem cells. We're also interested in the genes and the markers and what's happening with all of that. Again, we are about being innovative. We are about looking at advancing the most promising research. Tammy, give me a thumbs up or thumbs down if I've missed anything. Okay, good. All right, I'm gonna turn it back to Jen and Tony because the real heroes are about to be introduced to you. The real celebrities of this reception, short of Izak, and he will make an appearance. I was told, I was promised that. But then the celebrities that you're about to hear from are our heroes. Thank you all for giving me a moment.
Barb, thank you so much. Thank you for your time and just, again, being the driver behind this whole concept. So we're really lucky to partner with the Children's Heart Foundation. So as Barb said, at this time, it's our great pleasure to introduce two amazing medical professionals. Dr. Mark Lanowicz, MD, is the Murray D. Lincoln Endowed Chair of Cardiothoracic Surgery, the Chief of the Department of Cardiothoracic Surgery and Co-Director of the Heart Center at Nationwide Children's Hospital, and a Professor of Surgery at The Ohio State University of Medicine. He received his undergraduate degree from the University of Pennsylvania and was awarded the Fulbright Scholarship to conduct molecular biology research at the University of Geneva, Switzerland. He received his medical degree from Cornell University Medical College and completed his surgical training, including fellowships in adult and pediatric cardiothoracic surgery at Columbia Presbyterian Medical Center. Dr. Lanowicz joined Nationwide Children's Hospital in 2002 to head up the Department of Cardiothoracic Surgery, where he also serves as the surgical director of the heart, lung, and heart-lung transplantation programs. His clinical interests are in the areas of the surgical treatment and repair of newborns with congenital heart defects and cardiopulmonary transplantation. In his tenure at Nationwide Children's Hospital, he's completed the hospital's first successful heart, lung, and heart-lung transplants, including some of the youngest and smallest patients in the world. His work has helped expand the hospital's blood conservation program for congenital heart surgery, making the Heart Center an international treatment center for patients coming from all over the world. Additionally, he helped design the country's first hybrid congenital cardiac operating suite, allowing the technology first developed in the hybrid catheterization suites to translate into a state-of-the-art operating suite. His research interests focus on the development of innovative, less invasive strategies for the management of cardiopulmonary disease. Dr. Glanowitz's talent and expertise extends across borders as he performs life-saving operations with children with heart defects in developing countries.
Dr. Mark Rodefeld is a thoracic surgeon with Riley Children's Health and Indiana University Health, and an associate professor of surgery in the Department of Cardiothoracic Surgery at Indiana University. He completed internships and residence at Washington University and fellowships at University of California, San Francisco, and Stanford University. And his more than 20-year career includes emphasis on single ventricle Fontan physiology. Dr. Rodefeld's investigation has included work with engineers from universities and NASA in efforts to develop a blood pump that can act as the missing ventricle in single ventricle heart patients. And we are proud to say he is a 2014 research grant recipient from the Children's Heart Foundation for his work on cavopulmonary assist device development for Fontan circulatory support, as well as 2017 grant for Fontan blood pump advanced prototype testing optimization. Research funding from the Children's Heart Foundation helped to support his receipt of multiple grants from the National Institutes of Health, and his prototype of a Fontan blood pump is currently in an advanced stage of development. Wow, I needed 6.5 years to get my bachelor's degree. We are so fortunate to have both of these doctors on with us tonight. What these gentlemen have done to provide kids like Izak and the opportunity to experience quality of life is truly remarkable, and we cannot say thank you enough. And with that, ladies and gentlemen, I turn it over to Dr. Mark Lanowicz.
Well, first, I just need to clarify one thing. The true heroes are Jen and Tony, because the bravery that it takes to weather and maneuver through the landmines that a warrior like Izak needs to face from day one and on and on and on in his lifetime are scary, are real, and not sure how everyone can face that. And you have shown your ability to endure, not only endure, but persevere, and not only persevere, but have positivity and look towards the future in a way that has now led to this fund. And I hope, as Mark and I, both Marks, share, the importance of this is hard for you to really fully grasp, and it is incredibly important for Izak and for so many other Izaks of the world. I can't thank you enough. I understand that there's maybe in the 100 range of people who are a part of this, and not many are physicians. So I just wanted to give a little context of what Jen and Tony are the heroes of, and what Izak is weathering as a warrior. So fundamentally, there's acquired heart disease and congenital heart disease. Acquired heart disease, we're born with a normal heart, and then it gradually breaks down over time. It fundamentally breaks down over just 4 or 5 ways: too many cheeseburgers and hardening of the arteries, and you get a coronary bypass, valves that start to deteriorate, muscle that starts to weaken, rhythms that start to falter. But that happens in a lot of millions and millions of Americans. It's very well known. How to treat it is very well known. How to research it, the innovations are very well known. And we're all about 1 degree of separation from that. We all know someone in our family or friends who's been through it. And there are known environmental as well as genetic causes of those diseases that can be influenced and caused and used for prevention. Now, congenital heart disease is very different. That is being born with subabnormality of the heart, and the majority of which is not known to be driven by environmental causes, not enough vitamins during pregnancy, or even genetic causes. It's not that the combination of Jen and Tony led to a destiny for congenital heart disease. They already know that from their other son. It seems to be that something didn't go quite right on the day that that part of the heart was being developed. And that leads to an enormous difference of types of abnormalities that children can be born with. There's well over 200, 300 different heart abnormalities that the doctors and teams are facing with these children. So about 1%, a little less under 1 out of 100 children born have some form of heart disease, which is relatively common, but much, much, much less common than acquired heart disease. A handful of those heart abnormalities can be cured with a surgery or an intervention, but at least 2/3, if not more of them, have some sort of lifelong impact. Embedded in congenital heart disease is hypoplastic left heart syndrome, which is what Izak has. And that is amongst the most complex heart abnormality that a child can be born with. Not only is it complex in its anatomy and physiology, we'll go through that a little bit, it's complex in its treatments, it's risky in its treatments, and importantly, it has lifelong impact. Not only is it the most complex, but it is the most expensive congenital anomaly treated in the United States. And I'm talking about anything a child could be born with abnormal, whether it's in their brain, their bone, their intestines, their heart. Hypoplastic left heart syndrome is by far and away the most expensive care that is delivered in the United States for children. And it is far exceeds anything else that we treat. So the resource utilization, money, time in hospital is profound. And that's just that short-term treatment right at the very beginning. As I'm sure Jen and Tony will be able to share with you, there's a lot of focus on, oh, gee, that first surgery or those first couple surgeries in the first 6 months of life. Unfortunately, that's too much attention at the wrong place. Very quickly, the Jens and Tonys of the world learn that the big picture and the big questions they have to do with what will Izak's life be like? Can he play sports? Can he go to school? Can he run and jump? What are his brothers' life going to be like? What is our family life going to be like? How do we work? How do we vacation? How many days off do I need to take to get him to the hospital? What is the big picture? And then how does that impact the extended family? How does that impact our community, our church? And then the bigger questions of society and overall healthcare. But it all is a much, much bigger picture than this one first diagnosis and one first treatment. Mark Rodefeld and I have really focused our careers on children like Izak with hypoplastic left heart syndrome. It has become our mission, our passion, our calling to try and find ways to improve the quality and quantity of life for children like Izak, but also their families, to try and reduce the cumulative impact of the therapies that they need, and try and innovate, investigate, and develop tomorrow's solutions today. What I focused on was there was a lot of known risk surrounding the very first traditional operation called the Norwood procedure. And a lot of that risk not only impacted life and death, but more importantly, impacted complications that became lifelong issues for these children, but also could limit their opportunities for future developments and treatments if they were so impacted. And so we worked to help develop, refine, and champion an alternative strategy called this hybrid approach that Izak underwent. And we're proud that it does seem to have reduced some of the resource needs, reduced some of the complications. But at the end, all those children wind up needing this third operation called the Fontan procedure, which fortunately is a lower risk operation in general, but then creates a very unusual physiology that becomes a lifelong issue. So again, for all of those that are not medical and didn't know what a ventricle was, basically the heart has two sides. One side collects the blue blood from the body and then pumps it to the lungs to get oxygen. And then the left side of the heart collects that oxygenated red blood from the lungs and then pumps it to the body to feed all the cells that make us work, feed our brain, our kidney, our fingers, and everything in between. And that's oxygen. Hypoplastic left heart syndrome simply is half a heart. They fundamentally have really only one pump, and by the grace of God, the lungs turn out to be so low resistance that you don't have to have a pump to pump it through the lungs. So through this series of procedures, we can change the engineering, plumbing of the heart, if you will, and make it so all the blood flows through the lungs passively without a pump. Take the one good pump and make that be the pump to the body. And it works. The kids run and jump. They have a terrific quality of life. But there are consequences of that high pressure in the veins that is trying to push blood through the lungs. And it can impact the liver. It can impact the intestines. It can impact the heart itself. And so the longevity of this treatment is limited. How limited it is, we don't know for sure, because we keep improving things, which hopefully, as I think Jen and Tony mentioned, maybe 18 years, 30 years, 60 years before they need something else. Some of the innovations that me and my team were able to bring forward with this hybrid approach had to do with surgical modifications and utilization of currently existing things in different ways. The real disruptive, important research that will come requires true development of new devices and new medicines. And that pathway for pediatrics is unfortunately unbelievably cumbersome, unbelievably underfunded, and unbelievably underattended to. For example, all the moms and dads out there have no reason to know, but most of the medicines we give children have never been studied in children. Tylenol has, but Motrin hasn't. And that's because it just costs too much money for the companies to do that research and development. And there aren't enough patients that are going to get it for them to recoup their costs. So they just don't do it. And that is even more so in development of innovative new technologies. Mark Ronefeld is going to share a story that has to do with unbelievably important, brilliant idea that will have profound impact on children like Isaac early in their treatment and importantly late in their treatment. But the ability to do that kind of innovation and have the funds necessary, have the attention necessary, is extremely difficult. And the Congenital Heart Foundation was critical for him to take an idea to a prototype that then was enough of a proof to get that next big level of funding, which is NIH, which then allows proof of concept to then get industry attention to get it commercialized. But I think it's very important for all of the people to understand that congenital heart disease is a underappreciated, underfunded, and critically important for the research and innovation that's out there, for the brilliant minds that are out there to find a way to move their disruptive, innovative knowledge forward. I'm very, very fortunate to be sharing this meeting with Dr. Mark Ronefeld. He is brilliant. His idea for his research is so intuitive that it should be made available today, but because of all the obstacles that we just alluded to, he hasn't been able to. He frustrates the heck out of me because I've tried to recruit him in numerous times, and for all the right reasons, he's staying tucked in because of the team he's built and everything so that we can all benefit from it. So Mark, please take it over.
Sorry, I'm off mute now. So thanks, Mark. thank you for the kind words, and I really look up to you for what you've done. And you've pioneered a new surgical procedure, which is pretty mind-blowing, and few people, have been able to do something like that. So kudos to you, and thanks for all the kind words you've said about me. So I just want to say hello to everybody. Thank you for being here. Thank you for supporting the Szymczaks. I think you're all heroes. Izak's a hero. Jessica Cowan is a hero. Jessica Cowan is somebody who was a single ventricle and went through all the surgeries and went through Fontan failure, and fortunately got a heart transplant. And she's here, and she's now working to use her knowledge and talent to help other people with congenital heart disease and single ventricle heart disease. And so as a person who cares for those kids and those adults, I see the challenges every day. Most of you, or many of you, have seen the challenges, and there's nothing more important. But like Dr. Lanowicz said, a lot of the world doesn't know about this. This is a relatively common thing, and it is one of the most expensive problems that we deal with. It's one of the most frustrating problems that we deal with. And both Mark and I are driven to do what we're doing out of frustration from the challenges that we deal with. We can do, this is a surgeon talking to you, we can do a perfect operation and still have issues or problems just because of the physiology of the circulation that's set up as a consequence. It works. It's the only way we know how to do it. But people like Mark and I probably go back to our office or go home or wake up in the middle of the night scratching our heads saying, geez, isn't there a better way we can do this? And I think Mark Lanowicz and I probably are people who, like a lot of us, don't want to just continually do the same stuff different day. In other words, we're ingrained to constantly try to improve what we do. And that may mean that we put ourselves at risk. We may make ourselves look a little bit like oddities to our colleagues for coming up with different ideas. And I can tell you, and I'm sure Dr. Lanowicz would agree, I've had a lot of people look at me sideways and say, now, wait a minute, you're telling me you're going to do what? And, but Mark Lanowicz is right. And what's driving me and what I'm doing is basically normal human anatomy and nature. In other words, if I can get a Fontan patient's circulation back closer to normal, that chances are that's going to be better. So Mark Lanowicz described it. A Fontan circulation is just like a normal circulation, except you're missing one of the two main pumps. And so the idea of putting the missing pump back in is simple. It would replicate normal circulation. It should get health back to normal. But even though that's a simple and powerful idea, and that's what gets me up every morning excited about it, pulling this off and doing this is actually extremely complicated. And so I've spent 15, 18 years in different aspects of this, sort of finding my way through the dark room, trying to solve this problem. So Children's Heart Foundation has funded me twice. It was critical seed funding when I couldn't get funding elsewhere, when the ideas were too far out there for people to feel safe funding it. And innovative ideas typically come out of the box, and at first may seem a little too far out there, and it takes these critical early stage seed funding to get people further along, to really kind of prove it out and make the peers, our peers, feel comfortable that what we're doing has a sound basis. And so I'm a living example of somebody who has benefited from these funds to develop my prototype to the point where it was good enough to convince NIH, which is major biomedical research funding. It's your tax dollars indirectly, to fund this project at a high level. So my NIH funding was just awarded earlier this week. I knew it was coming for a while, but thank you. Yeah, it's great. Just awarded, and it's close to a $9 million total award. And about $6 million of that, will be funds directly directed towards the work. The additional money is indirect costs that helps with the university overhead and those kinds of things. So my story is interesting, and I did at least demonstrate early proof of concept with pieces and parts from the hardware store and Target, and demonstrated it in my garage underwater in a Tupperware basin, and filmed it with my iPhone with my wife's help and some other friends. And if you probably haven't heard me speak, but I often like to include that video in my meetings because, it was a $20 experiment that shows doctors exactly what this thing could do if it could get through all the hurdles that it would take to really get it to that level. So, it is a true to life garage experiment that started this. And, I'm one of those people like Mark Lanowicz that really, gets excited about thinking about things differently, because we know that what we do is good, but it's problematic. So anyway, that's a driver for me, and the early stage funding, no matter what it is, if it's $20 or if it's $100 or if it's more, it all comes together and makes these things happen. And, it advances our challenging in this field. So there's just not a big incentive for industry to support the development of a blood pump that may only go into 1,500 people a year. There's just the economics of that don't work out for people that invest money in device development. So to the parents of a single ventricle child, there's nothing more important. So anyway, I'm right there with the families. I'm not affected myself, but I live that every day. So I wanted to talk a little bit about the gap in life expectancy for single ventricle patients. So as Dr. Lanowicz said, we can do these surgeries and we can get a single ventricle person to live through childhood. When they get into adulthood, some problems begin to crop up. And it's not clear yet, what ultimate life expectancy is, but the thinking is that it's not going to be normal, that there will be a attrition or a failure rate. And currently, the only way to deal with that is a heart transplant, at least the only clear way to deal with that. If a blood pump can be developed and a circulation can be normalized, at least in theory, this is my vision, that 20 or 30 or 40 years of life potentially could be added to somebody's life, and at the same time with them reverted back to normal circulation and normal health. And so, there is a gap in life expectancy for single ventricle patients, and most doctors view it right now as, well, we can get a single ventricle patient to survive. And that alone is a huge feat. And prior to 1970, 1980, they just simply did not survive. Well, now they can survive and they can have pretty good quality of life, but we know, or it's beginning to come more clear that eventually problems are going to arise. And so, our success is essentially creating a new problem, and this new problem is becoming apparent because there are more and more people alive in the world with Fontan circulation. So anyway, there is need for continued advances and continued research. And I think a lot of people have the impression that a lot of congenital heart disease has been worked out, and maybe the need isn't that great. I've had the privilege of spending time with Dr. Fontan before he passed away, and I actually met with him in person for about 3 days, and really was able to talk to him about what I was trying to do and get his feedback. And it was clear that he knew that what he had started was a palliation. It wasn't going to be a curative solution. And he knew that someday that further advances would be needed, or something would be needed to address some of these long-term problems. So for me professionally, that was really a huge moment in my career to have spent some time with him and kind of get his feedback and pick his brain. So again, just to reiterate my thanks to Children's Heart Foundation. I believe their mission, and I believe that individual donors like you add up to make a huge difference. I'm living proof of it. And when I get my device ready for FDA regulatory approval, I will continue to have needs. And this NIH grant will get it through an important component of it, but it won't be all the funding that it takes. And unfortunately, these things to get fully developed and into human use requires a huge amount of money. So the donor support is tremendous and does make a difference. So thank you very much. Thank you, Barb. Thank you, Jessica.
Hey, Jessica, we wanted to ask a question, and I guess it doesn't matter who answers it, but so Izak is 2. If the blood pump comes to fruition, what is the likelihood that he could be a recipient of that?
So yeah, I'm always a little careful. I don't want to overpromise something that hasn't fully developed yet. And to be respectful, we'll be a little cautious about it. But any single ventricle patient, in theory, should be a candidate for it. There are a few situations where they may not, but I think for simplicity, I think it's safe to say that anyone should be a candidate. And as it exists right now, it's not in humans yet, and I think the simplest and easiest way to get it into humans is to aim for adult-sized people, and so that is currently where we're aiming. And I think people in general will be much more comfortable with an adult consenting to have that procedure done rather than doing it in a child until it's not, until it's proven. So if it gets to an adult, and if it is shown to be beneficial and has to get through all that, then at that point it is possible it could be downsized. If you put it in a younger child, it's going to have to be made smaller, and that's a little more complicated, and that child's going to outgrow it. So when Dr. Lanowicz or I put a heart valve into a young child, we know they're going to outgrow the valve, and we know we're going to have to come back and replace it. And with a Fontan pump, in theory, that would be the same issue. So my goal is just to get this to humans, which is going to be mountains beyond mountains. It already has been. If I get there, it'll first be in an adult size or an adolescent patient. The good news is that most Fontans do really pretty well through childhood, and it's not until they get into adulthood or at least adolescence, that they may begin to show some problems. So does that answer your question, Tony?
Absolutely. Thank you.
Yeah, sure.
Okay, we did have another question come in. If someone needs a heart, how common is it to actually receive one? And I think either Dr. Lanowicz or Dr. Rodefeld.
Well, I'll start and I'll let Mark also answer, but there isn't a simple yes or no, because, and Jessica, you could even speak to it as well, that for sure it depends a little bit on age, size, blood type, and coexisting conditions. Fundamentally, there are not enough hearts for those who need a heart transplant, and there aren't enough of any organs for transplant for those that need transplant. And so there's this awful reality of waitlist mortality. People who need it are waiting and don't survive. And you know, it's a very challenging world of transplantation, of triaging those who need it the most, but aren't so sick that they can't get to a transplant, or not so sick that they can't recover from the transplant. And so a lot of energy is also on, just using the heart as an example, heart failure management of how do we bridge to transplant so they can wait without getting worse and actually potentially get a little better so the rest of their body is in great shape and all they need is the heart. So the example in congenital heart disease and failed Fontan, right now we don't have a terrific way to bridge a failing Fontan to heart transplant, and there is a high likelihood of that type of a patient getting worse and worse and worse and not becoming a candidate any longer for transplant or dying while they're waiting. So the power of something like Dr. Rodefeld's Fontan pump is not only as a bridge to recovery, it could also be its own destination therapy in that you never need a heart transplant, or may completely alleviate that kind of possibility. So a cumbersome answer to what seemed like a simple question, but Mark or Jessica, comments as well to that question?
Jessica?
Okay. Thanks, Dr. Rothfeld. Yeah, to speak a little bit to that, when I received my heart transplant, I was 16. You don't really hear of patients waiting. I waited 3 weeks. So that is an incredibly quick turnaround from being listed on the transplant list versus the wait time to actually have your transplant done. Usually it's about 6 months to a year. It could be more, it could be less. I thought it was an incredibly quick period of time for me. But yeah, like Dr. Lanowicz said, there aren't enough hearts, and it's really scary when you're in that situation and you don't know what's going to happen in general. And then the need for a heart, you know, you're waiting for a heart, you don't know what's going to happen then. After you receive the heart, you don't know what's going to happen. It's just, you know, you take one day at a time once you receive it. I am so grateful and appreciative to my donor family. I'll be 21 years post-transplant next week. Thank you, everyone. Appreciate that. But yeah, I mean, I wish when I was born in '83, so that kind of gives you everything Dr. Lanowicz and Dr. Rodefeld are talking about. I'm lucky that things turned out the way they did back then, because there is so much, the research has progressed, the techniques have progressed. They know, doctors know what they're doing so much more than they did when I was born. So it's hard, like you're so excited and I'm so thankful, but you know that there are so many more people and babies and all ages waiting. And I was very sick. The sicker you are, you're inpatient at the hospital, you know you are the ones at the top of the list, especially depending on your age. I was younger, I was very sick. I was at the toward the top of the list, not at the top of the list. If you can survive, if you're a little less like needing a transplant immediately, you know, you might wait a year and a half. It all depends on the patient, on the level of sickness, even though, you know, at that point in time, everyone's sick when they need a transplant. But, you know, hearing Dr. Lanowicz talk about and Dr. Rodefeld talk about everything that they've been doing since like my time, and for Izak, it's like incredible the things that they know so much more about, that they can help Izak in such a better, bigger capacity. And I'm just a complete fan of Dr. Rodefeld, and I am definitely now a fan of Dr. Lanowicz, listening to him talk as well. So that's just my piece on at least the transplants.
I'm gonna jump in if that's okay. And I know we're, you know, after 6 o'clock, but to be honest, I don't care. It's our show. So we're gonna keep going unless anyone needs to get off. But I wanted to ask Dr. G and Dr. R. So, you know, Jessica has this anomaly, right? She's got this heart transplant and she's made it last, and you know, it's just amazing to see. And it gives parents like us, I mean, these are the stories we want to hear because it's just hope for us. Dr. G and Dr. R, can you kind of touch on lately, just, you know, a heart transplant it's you know, kind of the last go, and it's not a cure by any means. Can you kind of, you know, talk about that a little bit?
I'd be happy to comment. So yeah, heart transplants are life-saving, and clearly there's a need for them. There aren't enough donor hearts for all Fontan patients alive in the United States. And so the notion that, you know, when the Fontan fails, well, we have heart transplant, it's sort of what's said, but it's not a comprehensive solution. The heart transplant does have a different disease process. And one of the big problems with it that our science hasn't solved is chronic rejection. And that's true in general of virtually any type of organ transplant. We've gotten pretty good at acute rejection, meaning early failure, and we can get through transplants usually without that issue. But chronic rejection, you know, ultimately will take its toll. And so if you look at the survival curves for heart transplant at 5 years, 10 years, 15 years, those numbers can be a little bit concerning. Jessica, fortunately, has done great, and hopefully she will continue to do great, and hasn't had you know, those issues, and not all people do, but a fair number of them do. So while transplant helps us get to a next step, that brings in a different set of problems.
And I'll just expand on that a little bit, because I was at Columbia Presbyterian when this study was done. The Pediatric Heart Transplant Network looked at that question, because it may be intuitive. Oh, gee, hypoplastic left heart syndrome, so complex. Maybe we should just do a heart transplant in all those babies. And that was studied. And they looked at heart transplant as a primary treatment for hypoplastic left heart syndrome as the first operation. And there were a few centers around the country where that was the primary treatment, versus staged Norwoods, because this was in the 80s and only the Norwood existed. And so you have two sort of survival curves, those who had transplant and those who had staged Norwood to Fontan treatment. And the transplant patients did very well for 5-ish years because it's a simple, safe, low-risk operation. But then at 5 to 8 to 10 years, their survival started to continuously drop off, and I'll come back to the why. Whereas those that had a staged repair, they had a very sudden, pretty acute in the first couple years, drop off of survival because of the risks of the various stage surgeries. And then it plateaued for a long time, for a decade or so, and then it started to have these chronic problems that we talked about. And in and around 6, 7, 8 years of life, they crossed the survival curves. And so it was worse to start with the primary transplant. The primary reason of that is, as Dr. Rodefeld was alluding to, is the body wants to reject anything that's foreign. So heart transplant, any organ, and the body is eventually going to win out. It is going to reject it almost uniformly. On average, in a newborn or an infant, that's at about 8 years of age. Then if you retransplant, which is a thing, it does not last as long. And then it does not last as long. Moreover, the immunosuppressive medicines that try to reduce the likelihood of rejection reduce your body's immune response, and then that can impact infection as well as the development of cancers. And so a 100-year strategy for hypoplastic left heart syndrome does not make sense with transplant being the initial treatment. So it's reserved for those who need it when they really need it, to try and offset that clock. But that's an important question, and most families will ask that is, well, this is such a crazy heart problem, let's just do a transplant. And it's trading one disease for another, but it's not the better choice for newborns, at least.
Thank you. Hey, Jessica, in just to take into account everybody's time, I think what we want to do is kind of maybe close it. I know there's some questions that want to be asked, but maybe we'll just kind of close it out, and then those that want to stick around and ask questions, if Dr. Rodefeld and Dr. Lanowicz or Barb can stick around and maybe answer those questions, great. But to be cognizant of everybody else's time, we're going to close out here and then invite anybody who wants to stay on and chat and hang out. We certainly would love to see and hang out with you guys because it's been a while. But with that, I want to thank Dr. Lanowicz, Dr. Rodefeld for joining us today. I think the question that remains is, so how do we tie all of this together? What are we trying to do? And just to review, as we just talked about, there is no cure for CHD, more specifically HLHS. It's because there's a significant lack of funding directed toward research and finding a cure. So here's how Izak's fund is going to address the issues. Here's what we want to do. Our goal as a family, and that we put on paper with the foundation, is to raise $100,000 for heart research. And Barb has kind of gone through how all of that works. Our first milestone is going to be at 50,000. As we are told, 50,000 will fund one of these projects for a year's time. And once we hit that 50,000, we are going to take a look at these peer-reviewed research projects and either pick one or say, you know what, let's just roll and get to 100. But that's what we have decided to do. That's what we've committed to do. And that's what we are going to do. And we're going to do it with everybody's help. So this kind of was a call to action for everybody. We wanted to let everybody know what we're going to do. We wanted you to understand kind of what we've gone through, what the barriers are out there, but that's what we are committing to, is raising $100,000 for heart research. And as soon as we hit that, we'll reevaluate and see what our next step is. But that's our goal. So, you know, today was just a launch. We're going to keep you posted on upcoming events because we will do more. Izak's health updates and progress on the fund on our website. Today, we're asking for your help in spreading awareness of CHD, donating to the fund if you are able, and providing Izak and all other heart warriors with a chance to live a longer and healthier life.
And a very special thank you to Dr. Lanowicz, Dr. Rodefeld, Mike Tangretti with the Children's Heart Foundation, Jessica Cohen with the Children's Heart Foundation, Barb Newhouse with the Children's Heart Foundation. And we wanted to introduce our family. This is Bowden Szymczak. This is our almost 4-year-old. Say hello.
Hello.
And this is our heart warrior, Izak Thomas Szymczak.
Can you say hi?
hello.
Can you say hi?
Can you say nice to meet you? Okay. He's also very stubborn.
There it
Wave
is.
it.
There it
Yeah. Who do you have in your hand? Who are you holding?
Ducky.
Ducky, show Ducky.
I got my doggy.
Ah.
We like our animals here.
Thank you, everybody, so much for joining us. Again, if you have questions and want to stick around, we're going to stick around too. Please feel free to do so. If you need to run, please feel free to do so. You know how to get a hold of us if you have additional questions too. So thank you, everybody. Have a great weekend. And for those who want to stay, stay.
And Jessica, if you want to pick up and ask those.
Yeah, because the one question that people might, they're all the questions, but Dr. Rodefeld, this one question: what is the amount of additional funding that you would need to get your device to put to full human implementation?
Yeah, it depends on who you ask. Estimates to fully develop an implantable medical device, you'll hear numbers probably in the 30 to 40, maybe $50 million range. And when it gets beyond 5 or 10 million, typically investors will step in for that subsequent piece, because if it's addressing an important need, then there is enough of a business model to build around it. So the Fontan pump, for example, even though it's a limited market size, if I can get it through chronic animal studies and show that it works well, and I've de-risked the technology, I will likely be able to get it to the next step with investment funding, which will really then basically carry it through the rest of its clinical trials. And FDA does give a little bit of a buffer to what they call orphan diseases. I think probably all of the people on this call will take some issue with this being considered an orphan disease, but it's an illness that's less than 8,000 new cases per year in the United States. So hypoplastic left heart syndrome or single ventricle meets that criteria. And for FDA regulatory approval, a device needs to meet standards for safety, but it does not have to prove efficacy. And that efficacy then is proven out as the device goes into human trials. So anyway, it's a lot of money to get something like this into humans.
I'll just add, if I can just add one thing, having worked in healthcare research for a long time now and worked with the FDA for a lot. I know people will get upset because we know the numbers, et cetera, but the truth is we want to keep this in the orphan disease space if we can, because it's helpful to us to get done what we need to get done. Once it goes out of orphan disease space, the whole process becomes a whole different process and is much more complicated.
That's
so
right.
Just work with us and we'll get there. We'll get there. I have a whole nother idea, Dr. Rodefeld, that I'll talk to you about later.
Okay, sounds good.
And then the other question, Dr. Rodefeld, does your pump work similarly to an LVAD, knowing an LVAD is an external device?
Yeah, so the Fontan pump would be fully implantable. It is similar to an LVAD, except it operates at much lower pressure. It's probably a tenth of the pressure delivered as compared to an LVAD. So it's a type of blood pump that doesn't exist in any other example, and that's been part of the challenge here. Is it's 0 to 1 innovation. But that's what your right ventricle does in your body. It pumps at about a fifth of the pressure of your left ventricle. It's the right ventricle that's the missing pump. So this pump is targeted for very low pressure, but otherwise it is fairly similar to an LVAD, but it's fully implantable. And I think in order for it to work, it's going to have to be something that can be charged wirelessly across the skin. You know, a 20 or 30-year-old person is not going to want to live with a drive line coming out their side. So the wireless charging, I think, is going to be the way it's going to have to work. And I haven't gotten there yet. I have to prove the pump first. And I think if the pump is workable and doable and it looks good, then I think the technology for wireless charging is going to be there.
Dr. G, Dr. Lanowicz, maybe a question for you. What do you see as some of the biggest improvements maybe in the next 2 or 5 years, that 10 years, that could be impactful to Izak, whatever it may be?
I think some of it has already happened, which has to do with preserving pump function. So part of the goal of the hybrid procedure is to reduce the impact on the heart through the necessary surgery. So periods of time where there isn't blood flow to the heart, called cross-clamping, perturbations in the blood pressures and saturation that can cause subtle injuries. So I think a lot of the stuff that sets them up for a good 2 to 5 to 10 years has to do with reducing or eliminating injury during the necessary steps that he's been through. I think the next part is really after the Fontan, and Mark Rodefeld alluded to that as well, is really there's just this wonderful, at least decade typically, of remarkably normal physiology. And that's where it's important for you, because it's very hard to let them out of the bubble and go live a life, because the psychosocial elements of being in that bubble, to him, to his brother, and to you all, is very underappreciated. I think, you know, my wife is medical director of a camp for kids with serious illnesses, and one of the things we learned there, they have a sibling camp, because the siblings are so impacted by the amount of energy and attention, emotion that is being given to the Izaks of the world, that they need some time. And the stress, as you are very well aware of, on a marriage and on a relationship. And so that chunk of time that you're about to be given, it's very important to live life for your psychosocial health, for his psychosocial health. And that very much prepares him and you all for some things that may be coming down the line. Mark, your answer to that question?
Sorry, I was reading chat comments, so not paying attention. Can you restate the question?
Yeah, what do you see in the next 2 to 5 years?
Yeah. Sorry, I thought it was a question maybe that Mark Lanowicz had brought up. So what do I see as major advances? You know, I think stem cell research is interesting. That's basic science research, and you know, I don't do basic science research. I do more applied or translational research related, you know, closer to surgery. So, but anyway, I think stem cell research has great potential. It may be a longer timeline, you know, it may not be in 5 years or whatever, but I know there's a lot of interest in stem cell research and the potential for that. Otherwise, I think we're still learning about optimal medical therapy for Fontan patients, or even pre-Fontan. And just like Dr. Lanowicz said, you know, trying to preserve heart function and trying to optimize lung function, meaning keeping lung resistance as low as possible, lung health.
That's a perfect segue into my next question. So, we really didn't touch on this. This is just another factor of Izak. So Izak also has pulmonary hypertension. How do Dr. G, Dr. R, you see that playing a role in Izak's kind of future?
Well, it plays a very important role in that the Glenn and Fontan work, because the resistance in the lungs is low enough that passive low pressure venous flow is enough of an in pressure to go overcome that resistance. Flow is dependent on pressure in versus pressure out, and the resistance in between. Pulmonary hypertension is higher blood pressure because of higher resistance in the lungs. Some element of that we normally outgrow. There's a lot of lung growth that goes on from 0 to 10 years of age. And so some of that he may grow out of and still have nice low or low enough lung resistance. But if his lung resistance and pressure in his lungs is higher than normal or ideal, then that backup pressure in the venous system will accelerate some of the challenges of a Fontan, whether it be to the liver or the intestines and other things. So yeah, that's certainly a concern for him. And there's some medicines to help that. There's some time to help that. There's some preventive things to help that in terms of upper respiratory infections and things like that. But yeah, certainly that would be in everybody's mind.
And that's interesting because during Izak's cardiology appointments, that's always kind of a high topic for us. Has been infamously known to have higher pressures going into everything. So that's a concern of our cardiologists, at least is what we know.
It's pulmonary hypertension is a pretty poorly understood problem, and it's clearly need for additional research there to, and people have tried over decades, but it's still a pretty enigmatic problem that I think we still have a long way to go. Anyway, tends to be a relatively common problem.
Is that something you see actively being researched or talked about researched, maybe something that would potentially need funding?
Yeah, I think it is. I think a lot of that funding is more at the basic science level. And I know there are groups actively working on pulmonary hypertension. Whether it's related specifically to congenital heart disease, it may not be as clear. And it's very, like a lot of the rest of this, it's a very difficult thing to study. The Fontan pump, is going to have to be trialed in animals. Well, there's no animal alive with the Fontan circulation. So then how do you do that? And so I have to create a sort of a mimic or a surrogate of Fontan circulation in a large animal in order to prove it. So anyway, additional research and research support would be important.
Jen and Tony, one of the things that I'm going to suggest too is and I know you are already, I just know the two of you are, is start, if you start writing down your areas of interest, then when we are working with the American Heart Association, as well as in our independent, and we can start looking at those types of things. I think one of the things that you're going to begin to see in the next couple of years at the Children's Heart Foundation is that we're going to start to take a look at maybe doing 2 or 3 focuses in a year, as opposed to throw it all out and see what comes in. We are more likely, to start also doing some, I guess, focus group. I don't think focus groups is the right word, but some study sessions with like the 2 marks, and getting some ideas. What do they think is coming up and out there? So we're going to start. That's when I say that the Children's Heart Foundation is going to start upping its game, so to speak. And we have to do this all because I am going to retire one of these days. So we got to get it done. And we got to get the organization to $10 million before I retire, because Mike said I can't retire until we are. And so at any rate, I think it's important that we start to hear from you, Barb, these are the things that Jessica, we'd like to see, etc., so that we can start looking at that.
So I just want to come back to that question, Jen and Tony, about pulmonary hypertension. And as Mark Rodefeld shared, it is not all that well understood and all that well researched, and it's primarily looking at drugs. There is an enormous gap that has to do with pulmonary hypertension or even relative pulmonary hypertension in children with single ventricles. especially those in these younger developmental ages where there's still growth and development going on. And that's a total black box. What's the natural history of that? Where are there opportunities to intervene or improve whatever that natural history would be? When is it too late or too soon? It's an enormously important area, and it will become obviously relevant in how you think about Izak, but it's also going to become relevant in Dr. Rodefeld's research of how the heart pump might be used early versus late, et cetera. I think it's an enormously important area for research.
We had one other question come in quickly. Are there contacts at the NIH that we can petition for more funding for congenital heart disease?
You want me to take a stab at that one? Joseph, can I ask where you live?
I live in New Jersey.
In New Jersey?
Yes.
Okay. All right. So the only reason I did ask that is because there's a few approaches that we're looking at. Number one, we're going to make sure that Jessica has your name because she's also responsible for working with our advocates. And we usually will work an approach that is not, the NIH is not who we have to get to on that. It is the budget committee of Congress. So we've got to go through that. So what we will be doing is working through there's another organization called Adult Congenital Heart Association. There's Mended Little Hearts. There's several of us. And we'll try and pull together and make sure that and the American Heart Association, and try to pull together so that we're on target with messaging. And then we will unleash you all so that you can get to the people that sit on the Senate Finance and the Congressional Finance Committees to make sure. And then there's the Health and Human Services Committees. So there's a variety of committees that we've got to go at to get that funding. Believe me, if the NIH could have the funding, they would love the funding. It's not as simple as that. It's a very political thing that we've got to deal with it on. So does that help? Well, but you're just going to just love the fact that we now have your name.
Yes, I'm all in.
Okay.
Can I comment?
Sure.
So I'm a recipient of NIH funding, for a congenital heart disease project, and
On
so
my
I can tell you
phone. I don't know what's going on there.
there are people that I know that work at NIH that are pediatric cardiologists, and the program officer of my currently funded grant is a practicing pediatric cardiologist, and she cares for Fontan patients, and she cares for all CHD. So at National Children's Hospital. So there are, I can tell you, there are clinicians that work at NIH that understand what the clinical problems are and what the needs are. And they are advocates. They are people that, can be talked to, and but they do advocate for CHD research. It's just that the need has to be, the project has to be quite compelling and pretty advanced in order to get in, to the really big range on some of the funding. That's where the seed funding, is critically important to help these ideas kind of get out of the weeds. There also has been advocacy in Congress for CHD funding.
Yes.
And an example of this is Department of Defense funding actually has a component in it for congenital heart disease. Mm-hmm. And you may say, well, why does Department of Defense want to fund congenital heart disease? And it's because a United States senator has a child who has CHD or died of CHD, who stuck it in on the side. Yep. In order to help the cause. Now, that's not a front way to necessarily fund the cause. It kind of got done a little bit through a side route. But anyway, there are people within the system with access to the dollars, or who can have access to getting them there, that have ears and will listen. So anyway, I just want to kind of get that out to you guys to know that.
And they do, and they will listen, but it's really much better if there's a coordinated approach
Right.
on going at them, because if you just attempt to go at them, that can backfire.
Correct.
I've seen family groups do that.
Yep.
And all of a sudden a wall goes up.
Yep.
So let's work together on what's the right message, who do we need to see, and which trigger do we pull at what time.
Right.
Does anybody else have any other questions at this time?
And anything for Tony and I as well. If anyone has any questions for us, happy to answer. I know we've kept everyone pretty long. Thank you guys.
All right.
Okay.
All right. Well, everybody, thank you very much for joining us as we get ready to take on this next challenge. Thank you, Dr. Lanowicz, Dr. Rodefeld, Barb, Mike, Jessica, all of our friends, family for joining. It means a lot. And we will keep you updated and look forward to our next conversation. Have a great weekend, everyone.
Thank you
All
so
right.
much, everyone.
Thank you very much.
Thank you.
Bye. Thank you.
Bye.
Bye.
Thank you, guys.
Thank you.
Bye, Dr. G. Bye,
Thanks,
Dr.
Bob.
R.